Hi, let's talk about double angle formulas. In the previous unit, you talked about sum and difference formulas for the trig functions, and now we will talk about the double angle formulas. First off, let's talk with sine. Sine of x plus x. You guys know that this should expand to sine of x, cosine of x, plus cosine of x, sine of x. You can see how that's the same thing twice, and so I can reorganize this if I choose to as sine of x, cosine of x, plus sine of x, cosine of x. Simplified, this would turn out to be 2 sine x cosine of x. Let's take a look at cosine. Cosine's formula is cosine minus sine sine. Well, cosine times cosine would be cosine squared minus sine squared. Do not confuse this with cosine squared plus sine squared, which turns into 1. This is its own identity. Next is tangent. Tangent plus tangent over 1 minus tangent times tangent. Again, on the top you can simplify this as 2 tan over 1 minus tangent squared. And so there you have the double angle formulas, when you have the same angle twice, in this case x and x. Here are the formulas written out again. And let's take a closer look at cosine for a moment, because if you recall, you actually have some special identities with the sine and cosine squared functions. So let's take a look at cosine squared minus sine squared. If we wanted to replace one of those with one of its trig identities, we can say the cosine squared is the same thing as 1 minus the sine squared, with another sine squared involved. This would simplify to become 1 minus 2 sine squared of beta. Instead, if I had changed the sine function, my cosine would have stayed the same, but I would have a minus of 1 minus cosine squared. Distributing the negative would make the cosine squared at the end positive, where you would actually end up having 2 cosine squared of beta minus 1. And so those are two alternate versions of cosine's double angle formula. You have the original one highlighted there, cosine squared minus sine squared. And then you have these two alternate versions, which are nice because they are in terms of one trig function, either in terms of sine or cosine. And so any of those could be substituted in as a double angle formula. Let's rewrite these as a single trig function. 1 minus 2 sine of theta would be written as, well, it's the identity, even though it's a sine function, of a double angle cosine formula. So it is cosine of 2 theta. Remember, you have to double the angle. The next example we have here is a tangent function. I think it's obviously why it would be tangent. So it's the tangent if you were to double the angle. The next one is pretty close to the sine function, except that 4 out in front doesn't really work. So let's think of this in a different way. Let's think of this as 2 times 2 sine of 7x cosine of 7x. This is now my double angle formula. So the correct solution, as rewriting this as a single function, would be 2 times double angle of sine would now make this sine of 14x. Try these now. Pause the video to give yourself a little bit more time. Alright, let's see how you did. First off, let's factor out a 4 in this, which leaves you with 2 cosine. The 4 here doesn't change, because that's part of your angle. So it's 2 cosine squared of 4 beta, or b, minus 1. This would leave you with 4 cosine double angle, so it's cosine of 8b. In the next example, you can factor out a 15. Again, the 15 will factor out from the first term and the coefficient here to make that 2 sine squared, but the 15 will remain here with this angle. When you simplify it, it is 15, even though a sine, it is really a cosine double angle of 30 alpha. Here we can factor out a 5. It would leave you with the cosine squared of 5 beta minus the sine squared of 5 beta, which again is the cosine double angle formula. So that would be now 10 beta. And lastly, this one's a tangent one again, but there's one thing that's not quite what we like when that's at 3 out in front. So what I'm going to do is I'm going to rewrite this as 3/2 times 2 tan of 7x over 1 minus tangent squared. Okay? If you multiply 3/2 times the 2, you'll see how that coefficient turns into 3. By doing that, I now have the answer that I would like, which is now a double angle formula for tangent, and there's actually a coefficient in front of this problem of 3/2.